Welcome students, today is Wednesday, January 27th, and we are continuing our work with fractions. Today we are on lesson 3, exploring the area model. And I've got the multiplication table as I usually do inside of the slides. This is a resource for you. And the next couple of slides are going to be where you can put a picture of your work. Your teacher has to see a picture of your work. That means if you're working in your binder or in your notebook, to show your work to your teacher. Today, you're going to be able to expand your thinking of fractions by exploring how to model fractions using the area model, and also you're going to be able to create visual models and written explanations to explain your thinking. Our essential questions: why might it be important to understand equivalence, and why is unit size important in mathematics? Remaining the same for this unit, we continue to build upon them. And this is a little short video, recognizing equivalent fractions video. So what I want you to do is you're going to click right here on this link. You're going to click right in here and you're going to watch a little short video about recognizing equivalent fractions video. So go ahead and pause my instructional video, and I want you to watch the video for recognizing equivalent fractions. On our next slide, we have a scenario. It's called the launch jewelry box problem. And for this one, you're going to be able to use your Jamboard or in your notebook to solve this particular problem. And I'll read it. You can follow along. Jewelry box problem solving. Tina wanted to partition her jewelry box into 4 equal compartments. Then her grandma gave her more jewelry, so Tina wanted 8 equal compartments. Show how she could do this. What fractions do you notice when partitioning the jewelry box at different times? If Tina filled one part of the 4 parts, then partition the box into 8 parts. How many 8s would be filled? Okay, so you're going to go to your Jamboard, and I'll show you which one in a second, or in your notebook to solve this one. All right, so this is the Jamboard for the jewelry box problem solving, guys. And now you'll notice that there are 7 up here. This is really meant for, so if you're doing this independently and you're not in class, don't worry about the rest of these up here, because these are just duplicates. They're meant for group work. Okay. All right, so go ahead and reread it, and I want you to start trying to solve it as best that you can. Okay. Okay, so let's take a look. You've had an opportunity to work on the jewelry box problem solving. Tina wanted to partition her jewelry box into 4 equal parts, and that's what I've done over here. So you should have started out with 4 equal parts, 1, 2, 3, and 4. Then her grandma gave her more jewelry, so Tina wanted 8 equal compartments. Show how she could do this. How could she turn the 4 into 8? Where could we put our lines? If you notice now, I have, in order to make it 8, I just drew 2 more lines in there. I drew in the green. So now we have 8 equal compartments. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Now I'm hand drawing it, so it's not going to be perfect when you're drawing it by hand, but you're going to get as close as you possibly can. What fractions do you notice when partitioning the jewelry box the different times? All right, so now you've got this is 1/8. I'm going to erase the other numbers I have up there. So when I did it with eighths, each equal part now represent 1/8. So each one is now 1/8. Now when I still had the 4, when I had 4 equal parts, it's the same size, but it was just 1/4. It represents 1/4 each. It's just the more parts that you have on there, guys, the smaller the parts are going to be. That's the only way you can do it and keep the same size whole. So this one big one right here is considered the whole, and the one big one here is still considered the whole. All right, so what fractions do you notice when partitioning the jewelry box at different times? So you get 1/4, for the first time, and then we got 1/8 for each part on the second one. If Tina filled one part of the 4 parts, then partition the box into 8 equal parts. How many 8s would she fill? So if she filled one part of the 4 parts, so let's go down here to the 4 parts. So if she just, let's just say she just filled that one up, then she'll partition it into 8 parts. Let's say she went back and did the 8 parts. How many would it be? So let's just fill in what looks like would be the same up here. How many 8s would be filled in? So how many of these 8s are filled in? 1/8 and another 1/8. So essentially 1/8 plus a 1/8, 2/8. So she filled in 2/8 would be the equal parts filled in based off of this last question right here. Okay. Okay, so on our next slide, exploring color tiles. So here, guys, you're going to be modeling fractions using color tiles. Now, you're going to be able to use your color tiles that are in your manipulatives, your math kit that was given to you during distribution, or you're also going to be able to use our online version of manipulatives here. Okay. And so here we're going to create any 2 fractions with your color tiles. Now make an array of 4 columns of 2 tiles. Make each column a different color. Here's an example right here. So I've got, so you got 2 of them are colored red. 2 of them are colored red, 2 are yellow, 2 are blue, and 2 are green. So we've got, these are an array of 4. And there are 4 columns of 2 tiles. So we've got 1 column here, 1 here, 1 here, 1 here, and there's 2 in each. So the columns, 4 columns, and there are 2 tiles in each. And once we do that, there's some questions down here that we need to consider. What fraction of the array is red? How do we know? So for this one, let's take a look. What fraction of this array is going to be red? So there are 8 equal parts in here. 1, 2, 3, 4, 5, 6, 7. There are 8 equal parts. So 2/8 of it is going to be red. So 2 out of the 8 is red. So what fraction of the array is blue? It's going to be the same answer. 2 out of the 8 total are blue. So 2/8. How would you determine what fraction of the array is blue and yellow? So if we wanted to figure out that question, what fraction is blue and yellow, that means you're going to have to add up the total for the blue and the yellow. So that would be, there's 2 yellow and there's 2 blue. So that means that there would be 4 out of the 8. 4 out of the 8 is blue and yellow. So I'm going to click on the color tiles, the online color tiles. So all I need to do was to come up here. You click on the color tiles right here, and once you click on that, it takes you to a different screen. Okay, so I'm just going to represent what we already had. So you got 4 columns, and you're just basically dragging and dropping. And I'm using different colors here. And 2 green. So I have an array here of 4 different columns. So that's 1 column, 2, 3, 4 column, and there's 2 in each column. There's 2 in each column. And again, 2/8 of them are red, 2/8 of them are yellow, 2 out of 8 are blue, and 2 out of 8 are green. You're going to continue exploring with your manipulatives, guys. But here we've got some other examples that I want to go over with you. And let's take a look at the same ones here. How many 8s are equal to 1/4? So how many 8s are equal to 1/4? How many 4s are equal to 1/2? And how many 8s are equal to 1/2? And there's also a Jamboard, guys, associated with this one. There's a Jamboard associated with this one. And that Jamboard is right here. Okay, so go ahead and bring that one up. And We're going to take a look at our first question. So how many eighths are equal to 1/4? How many eighths are equal to 1/4? So first thing I want to do is for that first problem up there, and I'll just say number 1, I'm just going to go in and draw a rectangle, and I'm going to turn it into 1/4. And I'm going to shade in 1/4 of this one. Shade in 1/4, so that's 1/4. So how many eighths are equal to 1/4? So now what I want to do is I want to change this to eighths. So how do I change it to eighths? That means that I draw, remember on our exercise earlier, I just changed that to 8. So now I got 8 equal parts. So now when you look at it, how many of those 8 are shaded in? So now there are 1, 2 out of 8 are shaded in. So 2 eighths is equivalent to 1/4. So that's what that means. So I started out by drawing just the 1/4, and I had 1 shaded in, but I'm using the same figure. Remember, I'm using the same drawing, the same diagrams. They have the same size, and I just could partition it differently. I could divide it up into different equal parts. The first time I divided up into 4, but then I changed it to 8, but I didn't shade anything else in. So because I didn't shade anything else in, I could accurately look at it and say that 2 out of that 8 is shaded in. So now let's look at the second one. So how many fourths are equal to 1/2? So how many fourths are equal to 1/2? So now let's do 1/4. We're going to do that again. And we're going to shade in 1/4 right here. Okay, let's see if that works. And I'm going to go down. I'm going to draw, let's see, the exact same thing, 1/2. So let's represent 1/2 on here. Okay. So that's not enough up there. So that's not equal to that. So I need to shade in a little bit more. So that means that 2/4 is equal to 1/2. So now I can see easily that 2/4 is the same as 1/2 because the same amount is shaded in. So let's look at the third one. How many eighths are equal to 1/2? So now I'm going to keep my 1/2 right here. So now I want to change it into eighths. I want to change it in eighths. So how do I do that? Okay, so now I turn it into 4, and let's see, how can I do that? 1, 2, 3, 4, 5, 6. Now I got eighths. So how many eighths are shaded in? Wow, it looks like 1, 2, 3, 4 out of the 8 is shaded in. So that means that 4/8 is also equivalent to 1/2. So that's what that all means. So now on our next slide, we are back to our vocabulary, guys. So you've taken this down, written it in your notebook because it's really important. Equivalent, having the same value, equal parts, parts of the whole that are the same size, fraction, part of the whole that is split into equal parts, the numerator, which is the top number, and a fraction, and denominator, the bottom number, and a fraction. Partition means to break into smaller parts. So when you hear me use the term partition into equal parts, partition into 4 equal parts, or partition into 6 equal parts, that means you break it into those smaller parts. That's what partition means. So add that last one to your notebook, partition, and you also can do the drawing if you want. So next up, guys, we have an exit ticket, and this is on a Jamboard, and it's also on page 149. Now, if you need to go back and watch a little short video that talks about equivalent fractions, if you need a reminder, all you have to do is click right here, okay? Now, let's go to the Jamboard, and I'll show you which one you should be on. And again, that should be on page 149. You can do it in your binder. Remember, if you do it in your binder, you need to take a picture of your work and insert it in the slides. If you do it on the Jamboard, you can see it automatically. This says, use the pen tool to draw your model. Show what you know. Use the grid and or color tiles to show your understanding of equivalent fractions. Be sure to show all of your work. How do you know the fraction 4/6 is equivalent to 2/3? I want you to show me, how do you know that 4/6 is equivalent to 2/3? So that's going to take you to draw different models similar to what I've been doing already. So you finish with your exit ticket, guys. On our next slides, introduction to your independent practice. So you got independent practice, page 143. So on page 143, you got independent work. And remember to take a picture of your work and include it into the slides. Now, this is also on one of the Jamboards. So this one is also on a Jamboard. So 143 and 147. 143, 147 is what you should be doing for your independent work. This is after you finish your exit ticket. Okay. And just a reminder here, you finish your exit ticket, then you got to do the page 147 and 143. And also today you got Khan Academy. Correction on your last task, guys. Instead of Khan Academy today, 15 minutes of Dreambox. 15 minutes of Dreambox.